When looking at the unit circle long enough, you start to notice some patterns. We're going to talk about one of those patterns today, namely cofunction identities. Take a look at 30 degrees here. If we want to know the sine of 30, and we visualize this on the unit circle, this triangle right here, we go to the opposite side, which is 1/2, and divide by the hypotenuse. 1/2 divided by 1 equals 1/2. Therefore, the sine of 30 is equal to 1/2. Now, the pattern that I've noticed when looking at the unit circle, and you may have noticed already, is instead of starting at 30, what if we jump over to 60 and think about the cosine of 60? Well, the cosine of 60 would be the adjacent side 1/2 divided by 1, which is 1/2. What that means is that sine of 30 is the same as cosine of 60. If we were to jump up here to the 60-degree angle in the unit circle, we would see that cosine of 60 is indeed 1/2. And the reason for that is very, very simple. It's because if we switch over to 60, the opposite side that was from 30 was 1/2 is now the adjacent side of 60. Well, if we think about the definition of sine and cosine, they're both over hypotenuse. So if we switch the angle in a right triangle, the opposite side becomes the adjacent side, which means that if you switch the angle in the right triangle, the sine of the first angle is equal to the cosine of the angle that you jumped to, since the opposite side became the adjacent. So again, sine of 30 is the same as cosine of 60. They're both 1/2. We can look at it a different way. What if we started with cosine of 30? Well, cosine of 30 is square root of 3 over 2 because it's the adjacent over the hypotenuse. Now, if we look at the sine of 60, we will see that the opposite side is now square root of 3 over 2, and the hypotenuse is 1, meaning sine of 60 and cosine of 30 are all equal to square root of 3 over 2. Again, if we look at this triangle on the unit circle, now we have the opposite side is square root of 3 over 2, the hypotenuse is 1, which means that sine of 60, which is square root of 3 over 2, is the same as cosine of 30. It's all because when you switch angles, the opposite side, and I'll use an arrow here, if you switch angles, the opposite side that was with the original angle, so we'll call this O, if you switch angles, the opposite side becomes the adjacent side. And we know that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So when you switch, they become the same. If we look at 45 degrees, it's even more obvious. If we switch from this angle to this angle, it's still 45, and no matter how you look at it, sine and cosine are the same at 45. Let's look at 90. Notice that sine of 90 is equal to 1, but if we look at 0 degrees, cosine of 0 is also 1. Conversely, if we look at sine of 0, it's 0. If we look at cosine of 90, it's 0. Well, what do all these have in common? The angles that we're switching to, if we add those up, add up to 90. 60 plus 30 is equal to 90. 45 plus 45 is equal to 90. 0 plus 90 is equal to 90, and 90 plus 0. So basically, if you take the original angle, and let's say in this case 30, and you subtract it from 90 and jump to the other angle, well, the cosine of that is going to be the same as the sine of the original, and vice versa. What we're getting at is what's called cofunction identities. So the first one we have just learned, and simply because when you switch an angle in a right triangle and jump to the other one, you're effectively subtracting 90. For example, 90 minus 60 is 30, 90 minus 45 is 45. So for the first two identities, sine and cosine are paired with one another, meaning sine of 90 minus theta is just going to give you cosine of theta back, since the opposite becomes the adjacent, and the same is true for cosine of 90 minus theta equals sine. So the way I think about it is sine and cosine are pairs. Let's look at cosecant and secant. They work much the same way. Going back to the unit circle, what is the definition of cosecant? It's the opposite of sine, right? It's hypotenuse over opposite. So if we were looking at, for example, cosecant of 30, we would look at 1 divided by 1/2, which gives us 2. Now what if we wanted to know secant of 60? Well, secant of 60, what's the definition of secant? Secant is opposite over adjacent, 1 divided by 1/2. We see that when we switch from 60 to 30, that these two sides again switch. The square root of 3 over 2 becomes the height, and the 1/2 becomes the base, and vice versa. So we see a second pair. Cosecant and secant work the same way. Cosecant of 30 is equal to secant of 60, and so on and so forth. So the second cofunction identity is that cosecant of 90 minus theta is equal to secant of theta, and secant of 90 minus theta is equal to cosecant of theta. Now it's not just for angles on the unit circle, or at least standard angles. If, for example, we look at a non-standard angle like 15, we will see the same thing. In this case, you have the two angles of 15 and 75 degrees. What is cosecant of 15? It's square root of 6 minus square root of 2. So what is 90 minus 15? That's 75, right? So if what we are saying holds true, then secant of 75 should be square root of 6 minus square root of 2. And we will learn that later, but that is actually the case. Secant of 75 is square root of 6 minus square root of 2, the same as cosecant of 15, square root of 6 minus square root of 2. And as long as those two angles, for in this particular example, 15 and 75 add up to 90, cosecant and secant will always be equal to those angle pair opposites. So that's our second pair of cofunction identities. It looks more complicated than it is, but all it is basically switching the angle by subtracting it from 90, and that will give you the secant if you start with cosecant or vice versa. The third pair is, and again, the reason for that is if you switch the angle, the opposite side becomes the adjacent side. So in this example, cosecant is hypotenuse over opposite. When you switch to the other angle, namely 90 minus theta, you'll now be dealing with hypotenuse. The opposite side will now be the adjacent side, and therefore these two will be equal. The third pair is tangent and cotangent. I will spend the least amount of time explaining that because it goes back to what we just looked at here. Tangent is opposite over adjacent. So if we switch the angle, again, the adjacent side will now become the opposite, and vice versa. So in effect, you're flipping O over A to become A over O, and therefore tangent and cotangent will pair with each other. We can look at this again in terms of the unit circle. We see that tangent of 30 is square root of 3 over 3. If our theory holds true, then cotangent of 60 should be square root of 3 over 3. And indeed it is. We can look at 45, and it's obviously true. If you switch these, they're both 1. And so obviously if you hop to the other angle, cotangent of 45 is going to be the same as tangent of 45. Namely, 90 minus 45 gets you the same angle. This will also be true for 90 and 0. Tangent of 90 is undefined, so we would expect cotangent of 0 to be undefined, and indeed it is, and also for the zeros. So that's all cofunction identities are. The other way to look at this is in terms of radians. Now we know that radians is another way of explaining angles, and we know that pi over 2 is just 90 degrees. So if we go back to the unit circle and change it to radians, we will see that the same thing holds true. I do like to keep this angle in terms of degrees, although this is pi over 6, so you can see it up here. But we can see that if we do pi over 2 minus pi over 6, we will indeed get pi over 3, and those cofunction identities work the same way. Namely, sine of pi over 3 is equal to square root of 3 over 2. If we subtract pi over 3 from pi over 2, we get pi over 6, which will give us cosine of pi over 6, which should also be square root of 3 over 2, and indeed it is. This one might be helpful just to think in terms of degrees, and if you're looking at this in terms of radians, just think pi over 2 is equal to 90. So the bottom reads sine of pi over 2 minus theta is equal to cosine of theta, and vice versa. Cosecant of pi over 2 minus theta is equal to secant of theta, and vice versa. And tangent of pi over 2 minus theta is equal to cotangent of theta, and vice versa. That's it for explaining cofunction identities. The word cofunction just means they go together, co meaning together, and that means that they can be thought of in pairs. Sine and cosine go together as functions, cosecant and secant pair together, and tangent and cotangent pair together. That's it for this explanation. If you have any other questions about it, let me know.